Aldol condensation reaction is the reaction between aldehyde and aldehyde with acidic alpha hydrogen and cold alkaline solution. For example, sodium hydroxide or potassium hydroxide, to form large molecule of aldehyde having OH group at the beta carbons. This chemical reaction occurs in two steps. For example, two molecules of aldehyde react with one molecule of alkaline solute of sodium hydroxide or potassium hydroxide to form the large molecule of aldehyde with OH group at beta carbon. In the first step, some of the molecules of aldehyde meet with the basic solution, meet with the base. They are attracted by the base, but other molecules of aldehyde remain unreacted with the base, do not meet with the base, do not react with the base. So the ones which meet with the base, they tend to form inert ions. For example, in the first step, some of the molecules of aldehyde are attracted by the base. The base is a strong electrolyte. It does not exist in molecular form, but it exists in ionic form, like I have written here. The base, hydroxide ion, attacks one of the acidic alpha hydrogen to form the inert ion. This one attacks one of the acidic alpha hydrogens to form the inert ion. Negatively charged. And water is formed. Now, the inert ion is a nucleophile. Being a nucleophile, attacks the neutral molecules of aldehyde, the ones which have not met with the base, the ones which have not reacted with the base in second step. So in second step, the neutral molecules of aldehyde meet with the nucleophile, which is the inert ion. Now, this inert ion can be written as, right first, this alpha carbon. It has one hydrogen atom. It carries the aldehyde group. Then this alpha carbon, the negatively charged carbon, has a methyl group on the left side. Now, this negatively charged carbon atom, as a nucleophile, attacks this molecule at carbonyl carbon, at this carbon atom. Now, it attacks this molecule and the neutral molecule of aldehyde at carbonyl carbon. But this carbon atom is forced to form a total of 5 chemical bonds. 1, 2, 3, 4, and this is the 5th chemical bond. Carbon atom cannot form 5 chemical bonds. It forms a maximum of 4 chemical bonds. So the pi bond breaks down simultaneously, heterolytically, and it is all taken by the oxygen atom in order for the carbon atom to maintain having four chemical bonds. Now, this is the chemical species which is formed. This is negatively charged, the oxygen. This is negatively charged, the oxygen. But the water formed in the first step dissociate, as we know that water is a poor dissociating substance. It dissociates to form the hydrogen protons and hydroxyl ions as follows. Water dissociates to form the hydroxyl ions and the hydrogen proton. But the hydrogen protons formed are attacked by the negatively charged carbon, the negatively charged oxygen to form the large molecule of the hydrogen protons are attacked by the negatively charged oxygen to form the large molecule of aldehyde having OH group at the beta carbon atom. What is beta carbon atom? The beta carbon atom is the carbon atom next to the alpha carbon. And what is the alpha carbon? Alpha carbon is the carbon atom carrying the functional group. This is the functional group. This is the functional group. Being the functional group, it is attached to this carbon atom. So this carbon atom is alpha carbon atom. It is alpha carbon atom. Now, these hydroxyl ions formed react with the sodium ions remained in the reaction mixture. The sodium ions remained in the reaction mixture react with the OH group to form back the sodium hydroxide. So sodium hydroxide has taken part in the chemical reaction in the first step, but it is reformed at the end of the chemical reaction. So sodium hydroxide has participated in the chemical reaction as a catalyst. Now this is the product which is formed after the reaction between the cold alkaline solution and the aldehyde. And this is so-called the Aldol condensation reaction.